Hello, welcome to Ethereal Mechanics video number 11. In this video we're going to go over the elements of pain and the rules of acquisition recap. This is for general. If you don't know who I am, there's video number 1 which describes what Ethereal Mechanics is and gives an introduction. Pain is an acronym I use that combines paradoxes, anomalies, inconsistencies, and nonsense. Why pain? Pain is a set of symptoms which help us identify models or theories that could be wrong. Remember, rule of acquisition number 1, correct answers prove nothing. Just because you have a model or theory that gives you a right answer does not mean it's a correct model. We're going to discuss the severity of pain symptoms, red being lethal, find another model or theory. Orange could go either way. It could either be severe or it could be minor and it could be salvageable. Either way, it's going to require some work. Yellow is a minor problem, which is most likely salvageable. Okay, for paradoxes, we have 2 symptoms. We have paradoxes in general, like time travel. I'm not going to cover that. You probably know that pretty well. Conundrums. A conundrum is, it's like a paradox, and we're going to discuss conundrums in upcoming videos in Newton's laws. And so, you can go look up the definition of conundrum, but it results from an overly idealized model or theory. So they're usually salvageable. So even though Newton's laws I'm going to show have a conundrum, I'm going to show in a later video, I think it's 17, 18, and 19, that conundrum is actually resolvable and will make Newton actually a stronger base of models. Okay, then we have anomalies. An anomaly is an observed manifestation that is not predicted by a model or theory. Like, for example, the way planets were not predictable under the models before Galileo. They were just wandering objects, and they didn't go away. Then you have theoretical anomalies, which are anomalies that theories predict, but have not yet been observed, like, for example, dark matter. Then we have inconsistencies. For example, an inconsistency is when a model gives a wrong answer, or basically it's inconsistent with observation. And then you have violation of laws, like, for example, conservation of energy, conservation of mass. Then there's nonsense. Nonsense is kind of like a catch-all for all the other anomalies or paradoxes or whatever that just don't fit under the other categories. In my opinion, the nonsense ones are the most severe. That's why most of them are red, and there's more of them. We're going to cover what each one of these things means. So this is just the intro to this section. There's 8 nonsense properties of nature. Sentiency. Sentiency is one of the first nonsense ones, and that's where a particle is required to know what to do. For example, in Lenz's law, when we have a coil in a magnetic field, we say that, the current will act to oppose. The current is going to act to oppose the change in magnetic field. How does the current know that? Okay, that's just one example. Then you have action from quantum mechanics. In quantum mechanics, they use stuff called Lagrangians, which use energy to try to predict the action or behavior of particles. For example, you have the Higgs field, and they say that the particle wants to go to the lowest energy point. Well, how does the particle know to do that? Okay, so I don't buy anything that requires particles to be sentient. When I show you the new electromagnetism version of this phenomenon, we're going to show a field that looks like this, where this is a positive force field, this is a negative force field. Positive force field will direct the particle this way, the negative force field will direct the particle this way, and it will be stuck right at that. If I were to invert this, it's going to look something like this. So the particle is going to get stuck in that little channel. It doesn't have to know what to do. The field is going to force it to do what it's supposed to do. So we don't have to require particles to be sentient. Ambiguity and disconnection. Ambiguity is Faraday's law. For example, if this is a changing magnetic field, and this is a loop of wire, and the field goes beyond what we show here, then according to Lenz's law and Faraday's law, it's going to produce a current that's going to oppose a changing magnetic field. Therefore, if we take this little point, that means that the current at this side of the loop is going to go this way. The current at this side of the loop is going to go this way. The current at this side of the loop is going to go this way. And the current at this side of the loop is going to go this way. So if you didn't have the loop, the charge would not know what to do. Okay, that's an ambiguous model. The other problem is disconnection. How does this little change in flux here impart an EMF on the wiring out here? Here we have cause and effect that are disconnected by time and space. I have big problems with that. Okay, and the other thing, it doesn't tell you where the EMF. That's another form of ambiguity. This change in magnetic field here, does it impart more EMF in this side of the loop or this side of the loop? It doesn't say. It just doesn't say. And then you have Archimedes' principle, which says if I have a boat and it displaces water, this water that was here that is now displaced is going to help buoy the boat. The question is, how does this displaced water that was supposed to be here apply its force to the hull of the ship? Well, Archimedes' principle doesn't tell us that, and we have to use Pascal pressure models, which were developed over 2,000 years after Archimedes, to give us a more complete understanding of how the pressure on the ocean acts on the hull of a ship to keep it buoyant. So I do not buy ambiguous or disconnected models. Energy derivation. In electromagnetic theory, they have a derivation for a tubular wire, and I think it's I forget what I forget what the derivation is offhand right now, but the point is that it's irrelevant to the diameter of the wire. So what it says is that, and because there's no force model for this, Faraday's law does not apply to the intrinsic induction, or they can't make it apply. So they tried a backdoor approach using energy to derive the intrinsic or internal inductance of wire. Unfortunately, they got a wrong answer. And if you go to my thesis online, I'll show you a simple experiment which shows this is a completely wrong model. Same thing with a Lagrangian. Quantum mechanics uses a Lagrangian to determine particle behavior. Unfortunately, when you try to derive particle behavior from power or energy, which this is the technique used, energy only tells you what could happen, not what will happen. Once you know what could happen, you need probability and statistics to give a high probability of what might happen. So you have basically an ambiguous model there. Again, when we show you the quantum mechanic derivations with new electromagnetism and ethereal mechanics combined, we're going to show you a force model that will tell particles what will happen, not what might happen. All right, so let's recap the rules of acquisition. That was the rules of pain, okay, which helps us determine which models are bad. Let's recap the rules of acquisition. Now I'm going to go quickly through these. I'm not going to read them all. I'm going to pause. I may discuss a couple of these, but for the most part, we're just going to go quickly through these. And I'm not just going to read them quickly. You can read the rest by pausing. Number one, correct answers prove nothing, because wrong theories can give correct answers too. Number two, it only takes one wrong answer to prove a theory wrong. That's based on number one. Number three, bad theories are like the wrong path in a maze. The sooner they are abandoned, then the quicker the maze can be solved. We identify bad theories or models. We look for pain, paradoxes, anomalies, inconsistencies, and nonsense. Number five, where there's pain, there is gain. If you go after the anomalies, you'll find interesting things about science you never knew. And those are going to be showing up in some of the next videos. Number six, if you have to stand on the shoulders of giants to see farther, then the giants are standing in the way. Number seven, if everyone is thinking alike, then somebody isn't thinking. General George S. Patton. Number eight, the best way to expose a bad theory is to apply it in the real world. That's derived from what Lincoln said, and you can read that on your own. Nothing is perfect. No exchange of energy is perfectly 100% efficient. No reaction is perfectly instantaneous. No reaction is perfectly equal. And you can read the caveat on your own. Okay, do not derive a theory from observations. We went over that in a previous video. Theories are infinite, so don't get hung up on the first theory that gives you a correct match of your observations. Okay, read the rest on your own. There's only two types of theories, wrong theories and theories that haven't been proven wrong yet. And when we human beings assume we know something is irrefutable, the junk science curve goes flatline, and we make no progress toward getting to the correct line, the green line, which means the truth line. The improved scientific method, you can read that on your own. We're going to be doing that in a later video. I forgot which video it is. Models are just a means to mimic. Even models derived from wrong theories may still be useful. But if a model fails to mimic the phenomenon under any condition, the underlying theory is certainly wrong. Models have limitations, usually for two reasons. Most of the time, models are incomplete. It may be impossible to get a complete model. And most often, model theories are going to be wrong, and models derived from wrong theories are going to be wrong, or going to be incomplete. Okay, remember, mathematics is a superset of nature. Just because you can derive something does not mean it's true in the physical universe. Because remember why. In mathematics, we can derive universes of infinite dimension, even fractional dimension, whereas scientists today believe that our universe can be described with merely 12 dimensions or somewhere in that order. Therefore, it's possible in mathematics to come up with infinite possibilities that just don't exist in our universe. 17. Ambiguity is for mystics. That's what we talked about in the pain section. Ambiguity is a hallmark of fortune tellers, religions, and junk science. If a model or theory is ambiguous, jettison it immediately, and we discussed those earlier. Use the force loop. If there are no force models to describe the behavior of a system, then something is wrong. Do not accept backdoor techniques such as energy derivations or statistical models. A force describes what will happen. Energy only describes what could happen. Number 19, disconnect from the disconnected. We talked about disconnected models. You can read that on your own. Okay, use Columbo's methodology. Don't ignore the little details. They may keep you awake at night. Don't stop asking questions, even after everyone else thinks the mystery is solved. Luckily, we don't need a warrant to do research, and treat observation as witnesses, theories as suspects. There's an interesting highlight for Columbo Season 1, episode Deadweight, where he goes to the guy and says, gee, you have a real nice fireplace here, but how do you start a fire without those things? What do you call those things? And the guy says, oh, andirons. Yeah, andirons. How do you have a fire without andirons? And the guy says, oh, well, I don't really make fires. I just turn the thermostat up when it gets cold. And then Columbo says, well, why do you have all this wood stacked over here then if you don't use the fireplace? Oh, he goes, that's for show. And then Columbo says, well, gee, I'm thinking to himself, obviously, if the guy's got wood for show, why doesn't he have andirons for show? And andirons are those things in the fireplace that look like this. And they're usually very heavy steel. In fact, it turned out the andirons were critical to solving the mystery. They were actually used to weight the body down so the guy could dump the body at sea. Okay, so we're done with the recap. Okay, what's next? We're going to return to the quest for the ether. We've got 5 pain videos coming up. And then a fixing Newton video, because like I said, gravity violates Newton's third law. That's an inconsistency, but there's a conundrum in Newton's law up here we're going to fix, but Newton's third is going to go down. We have an antenna paradox, which is very interesting. The antenna people will love that. But the most important one is number 21. That is going to be the most important revelation in probably the majority of the videos. That's going to be the one. If you don't see any of the other videos, just see number 21, which will be out sometime in April. Thank you. Please contribute.